Hey everyone. So now that we have calculated the mean trip duration, right? Okay, so the mean is what we sometimes refer to as the average. I'm actually going to label this more specifically as the mean. We also want to calculate the median, okay? And as we discussed briefly in class a couple of weeks ago, the reason why we want to do this is because we don't know which one is the better measure of central tendency until we know a little bit more about our data set. And so it's handy to just do both at the outset because we won't know sort of for a while basically which one is more appropriate to use. Where we have high variability, we probably want to use the median. Where we have low variability, so there's sort of consistent, what we call that traditional bell curve shape to the data, then we can use the mean. Some data is like that, some data isn't. Generally, there is not that much what we would call normally distributed, which is weirdly pejorative, weirdly normative, as it would happen. That bell shape curve we're not actually going to find in a lot of data sets. Mostly we're going to find data sets that are skewed, where there's outliers either at the lower end or the upper end, and so the median is going to be more appropriate. But for our purposes, we're going to calculate both because both are helpful at different points. And they allow us to do different things. So I'm going to start by selecting all my data. I'm selecting by row here in the left-hand gray area, specifically because I don't want to capture my calculation down here. If I selected by columns, then that would get sorted into my data set, and I don't want that. So either one will work fine, but in this case, because I have some extra data down here, I don't want to do that. So here we go. I'm going to, again, do a custom sort. I'm going to choose to sort on trip duration. Now, why am I sorting? Because the median is literally the middle value of a data set, okay? So I can't know what the middle value is if they're not in order. So the important thing here to remember is that anytime we're looking for the median of a data set, we need to sort on our data and make sure that it's in order. And so here we go. I now clearly have this in order, anywhere from 188 seconds all the way up to 3,696 or 695. I'm guessing that was two people probably traveling together. It does seem like they started and ended at the same time and stations. In any case, so finding the median is really quite simple because it is literally the middle value. So now that my data are sorted, all I need to do is look for the middle row. So if I have 33 rows, right? What I'm looking for, so in an odd number of rows, what we are going to choose is the middle row. So in this case, it's going to be the one that has 16 above it. I always find this a little counterintuitive when I'm dealing with a header row. But basically, the way I like to think of it is there's the same number above as below. So in this case, I'm going to actually come back to my home tab. I'm just going to highlight this, okay? This is my median row, okay? So the median row in this case is row 18 because I have 33 rows. So it's going to be the 17th row is going to be the middle row, right? That means there's going to be 16 above it, 16 below it. Okay, so I can even do this and count. See, I get 16, and over here I get 16. Everything looks good. So, but the median value, right, is the value of my metric that appears in that row, right? So in this case, the median value, the median trip duration is actually 1176, okay? I'm very annoyed that keeps doing that. I have to now change my formats. 1176, and if you haven't dealt with this in Excel, I can come, this is my context menu, I'm going to say, somewhere I'm going to say format. Where's format? Format cells. Right, there we are. And it's going to give me a dialog. And by the way, I'd like this to be a number. And again, I'm not adding accuracy here, so it's just going to be a single. It's going to end in 6. Okay, so that's it. That's actually all there is to it. That is my median. Now, we're not going to stop with the median. We're also going to look at something called quartiles. We'll talk about why quartiles are important. This is my favorite image for quartiles, for demonstrating what a quartile is. So again, if the median divides it it is hopefully a little bit intuitive. So try to just think about the language first before you try to think about how to get there. Quartile, quarter, okay? The median divides our data set in half, and the quartiles are going to divide it into quarters. So basically we're going to divide each half in half. That is really all there is to it. So in this case now, of course, we will inevitably encounter the situation where we have, even if we had an odd number to start with, right, we now need to divide each of the halves in half. There are a few different methods for doing this. I prefer the one where we exclude the median itself. So you can see that I am just worrying about what is the middle of these 16 rows. Of course, we cannot have the middle of 16 rows, so we're going to choose the two middle rows, and I'm going to opt to average the values, okay? So what does that mean? If I have 16 rows, I can have, it's going to be the two in the middle, and it's going to be 7 above and 7 below. So 1, 2, 3, 4, 5, 6, 7. Okay, so these are going to be my two quote unquote middle rows. I'm going to go ahead and make these orange, okay? Right, and again, how can I double check this? Well, there's 7 above, there's 7 below, and so this I'm going to call, now this again is a little bit confusing, so if we think about this going from top to bottom, okay, Q1 is in the lower part of the data set, right? So we go from 0 to Q1, Q1 to the median, which can also be called Q2, Q2 or the median to Q3, okay? And so this value that's higher in value, although it's visually lower on the page, is actually going to be Q3. Okay, so I'm going to say Q3 is now, it's going to equal, so I can do this a couple of ways. I could do it manually. I'm going to do this just so I can practice doing my sum and division. So I'm going to say equals sum, and I'm going to select my two entries here, divide that by 2. Again, I wouldn't want to add, I can't add precision here, so I'm going to say round. Okay, and the reason why I'm putting 0, there's 2 arguments to this. Yeah, I don't care about that. Shut up, Excel. The reason why I'm putting 2 arguments to this is that the round function actually needs 2 ingredients, okay? It needs, and it's showing me this little highlight right now, it needs the number, so the thing that I want to round, which in this case is the sum of those 2 rows, divided by 2, and then the number of digits I want it rounded to. And so since my whole point here is that I want 0 digits after the decimal, the entry is 0. If I wanted something more precise than that, if my data were originally more precise, then I could use that. So Q1, okay, don't know why I started with Q3, I just did, is going to do, I'm going to do the same thing up above, right? So I'm going to count 1, 2, 3, 4, 5, 6, 7. It's going to be these 2 rows. Okay, I'm going to, again, I like to highlight. It just makes it very easy. So again, Q1 is not rows 9 and 10. That's not the value of the median. The median is the, in my case, the average of the data values that appear in rows 9 and 10. Okay, so I'm going to do here equals sum these 2 divided by 2. I'm also going to round this to be a single digit. Now, I will point out that some of the stuff that we're going to talk about next week involves using things like the mean or the median or Q1 or Q3 as base values. In fact, we're going to talk about that right now. I would never want to do this rounding before I finish my calculation, right? So rounding is always something that happens at the end of a calculation. For the moment, this is as far as we're going, and so it's fine to do the rounding now. If I were using these as values to be inserted into a future equation, I would always use the unrounded values there. So just to kind of clarify that a little bit, it'll become more clear when we do those calculations. And so just to kind of preview what we're talking about, what we see here is this is our quote unquote normal distribution. This is a bell curve, okay? This is the way that we see a lot of things distributed in nature. That's why it has that quote unquote normal curve. Probably for most of us, our greatest exposure to this is if you ever took tests in college sometimes, and you talk about anywhere, maybe in high school, at any time, if someone's ever talked about grading on a curve, this is exactly what they mean. What they mean is that, and this is the assumption, right, that within a given class, let's say, that the majority of students will be should fall sort of in the middle, and that only a very few should score very well and only a very few should score very poorly, right? And so what they are doing is they are essentially trying to force a normalization of the distribution of scores, which I don't think is a great strategy, but that's another matter. Basically, the point of this is that the special properties of a normal curve let us make inferences about how, and in general, our measures of median of central tendency and spread help us make inferences about how typical or unusual a particular value within a data set is. And again, this all comes back to context. What we really just want to understand is how typical is value X, how unusual is value X. So what we're looking at here is, in this case, in a normal distribution, the median and the mean are the same. Okay, if you have this kind of bell-shaped curve to your data. The mean and the median are the same, and this is showing what percentage of the total data values will fall between these certain measures, right? So it's sort of intuitive that 50% of the values will fall between Q1 and Q3, since each one of them represents the boundary of a quarter of the data set. What's between them should be half the data set. And likewise, and so then the other half would be out here. This value up here, which we'll calculate next week, is called the upper bound. This is called the lower bound. In the case where we have a normal distribution, there's a different standard. There's a different sort of standard measure we can use that is called the standard deviation, okay? And we will go over how to calculate this, but basically, just the way that Q1 and Q3 tell us where 50% of the data lies, we know that within one standard deviation of the mean in a normally distributed data set, in a bell curve data set, we will find 68.27% of all of the data. And then the majority of the remainder will be between 1 and 3 standard deviations, right? And only a very few data points, a tiny, like a vanishingly small number of data points, will be more than 3 standard deviations away from the mean. Likewise, we can see by the way that the upper bound and lower bound map against this that we know that it's very that basically anything that is outside, that is below the lower bound or above the upper bound, again, is sort of statistically unusual, okay? And the reason why this is important, again, is because one of the key functions that we're trying to establish here is understanding how unusual something is. So, for example, we might look at a trip like 3696, right? 3,000, almost 3,700 seconds, and say, wow, that's really unusual. That's incredibly long. Why? Because, well, there's only 2 of them, and the next longest trips are like half that value, right? But is it really unusual from a statistical perspective? And that is exactly what we're going to determine. So that's all for this week. We're going to talk more about these concepts in class, and then next week we're going to look at how to actually again, use those measures of spread to determine how unusual a particular value is. All right, see you soon.